Here we are going to be doing question 23 or problem 23 in chapter 2 of the AP Physics textbook on page 51. So it says, a speedboat moving at 30 meters per second approaches a no-wake buoy marker 100 meters ahead. The pilot slows the boat with a constant acceleration of negative 3.5 meters per second squared by reducing the throttle. A, how long does it take the boat to reach the buoy? B, what is the velocity of the boat when it reaches the buoy? So we're going to start out like we normally do. We're going to visualize the problem. Here's our buoy. .100 meters ahead, and the acceleration is negative 3.5 meters per second squared. Okay, so we're going to say xi, initial position is 0, and then final position is 100. So part A is asking how long does it take the boat to reach the buoy. So let's write down our knowns and our unknowns. We know initial position. Oh, I'm sorry, I forgot to check to see if we needed to convert anything, and it looks like we don't. So we know our initial position. We know our final position. We know our acceleration. And again, I'm not including units here because I already know that everything is in correct units. Initial velocity is 30, and we're looking for time. So which kinematic do we want to use? We want to use our second kinematic. So let's just rewrite it. And we want to use the second kinematic because it's the only one that does not involve final velocity. And we are not asked to find final velocity in this problem. So let's go ahead and plug and chug. So we have 100 here, 0 here, plug in 30, negative 3.5 for the acceleration, and there we go. So now we end up with so we're going to have to use the quadratic equation for that, not the aquatic. I'm not quite sure what equation that would be. So let's, it bothers me when this term, the term with the square, is negative. So let's switch it over. So to solve for t, we need to use the quadratic equation. And one thing I would strongly suggest for this class is you get the quadratic equation. On your graphing calculators, there's like a program for it where you can just plug in A, B, and C, and it'll spit out the numbers for you. Unfortunately, my graphing calculator broke over the summer, so I'm going to be using the quadratic equation solver I have on my smartphone. You can download the quadratic equation solver on your tablets or your smartphones, but I will not allow you to use it on tests. I will, however, allow you to use your graphing calculator on tests. So if you have it on your graphing calculator, you're welcome to use that. Anyway, here's what it looks like. So my A is 1.75. B is -30. And C is 100. Press done, solve. So we've got, and I'm going to round here, T equals 12.61 and T equals 4.53. So, why are there two numbers here? And which one do we want? They're both positive. So, here's the deal. It's the lower number that we end up wanting. This is how long it takes the boat to reach the buoy when it's slowing down. The second number we found is if the boat continued to travel with this acceleration. So it's like if the boat slowed down, passes the buoy at 4.53 seconds, continues to slow down, maybe gets to a zero velocity somewhere here, or probably further down outside of my screen, and then once it slows down to a stop, uses this acceleration. So this time it would be negative velocity and negative acceleration, so therefore speeding up, but speeding up in the opposite direction. So this second time here is how long it would take from this time here to go past the buoy, stop, turn back around, and pass the buoy again. So sometimes you'll find that you have two times when you're solving for time, so you have to really think about what that actually means. Okay, let's do part B. Part B is asking for, let me just check, the velocity of the boat when it reaches the buoy. So this would be VF. So there's actually a couple different ways you could do this. You could use the first kinematic because now we have time. I prefer to use the third kinematic in this case, which is VF squared equals VI squared plus 2A XF minus XI. The reason I prefer to do that is because this is basically a derived quantity, so I want to use all of the numbers that are like pure from the original problem. So this number I would consider to be not quite pure, and you can read into that if you want. Okay, so VF squared is going to be equal to VI squared, so 30, negative 3.5 for A. I'm just going to X out that XI because it's 0, and then XF is 100. So, plug that all into your calculators. I meant to calculate that ahead of time, but apparently I didn't. Sorry about that. Give me just a sec. Okay, sorry, it's 200. Then you take the square root of both sides, and you end up with 14.14 meters per second. So the boat is still going pretty fast when it passes the buoy. So it's going to take another quite a long time to slow down, and then come to a stop, and then speed up again and pass the buoy. And we know what time that would happen at. It would happen at 12.61 seconds.